represent functions as rules and tables. Start out with some notes here. So a function, and if you see me abbreviate like that, FNCT as an abbreviation for function, consists of a set called the domain containing numbers called inputs, which are the x values. So if you hear domain, they're talking about the x values of basically your function. And then the y values are a set called the range containing numbers called outputs. Which are the y values. And it is a pairing of inputs with outputs such that each input is paired with exactly one output. So we have something called mapping diagrams, which help us to determine essentially if a set of values is a function or not. And the way that we do that is we set them up as like an input row or column and an output column, and we see if anything is used twice. So basically, no input or x value can have more than one output. Or y value. However, the reverse is not true. We can have multiple uses of an output. So the y values can be repeated, x values cannot. So an example of what one of these would look like, basically we would have an input column and an output column. And I could have the numbers 1, 2, 3, and 4 in my input column, and 0, 1, and 2 for the output. So a mapping diagram shows what the inputs match to. So we could have 1 goes to 0, 2 could go to 1, 3 could go to 2, and 4 could go to 2. And this would be a function because each input value was used only one time. So if an input is used more than once, it is not a function. So we can do this with a mapping diagram. You also might have it where they just give you a table of numbers and you're looking to see if any of the inputs or x values are repeated. So an example of this is, I have a table here. Got 3, 6, 9, and 12. And then my output values are 1, 2, 2, and 1. So are any of my input values repeated on this one? No, so this would be a function. What about if I had in my table 2, 2, 4, 7, and then 0, 1, 2, 3. Are any input values repeated in this one? Yes, so this is not a function, because we have 2 being used twice. So another word, you may have heard it in science. If you haven't heard it in science yet, you will. But we have an independent and a dependent variable. So our independent variable, it's very similar in math as it is in science, but the independent variable is our input value, also known as what is being changed. The dependent variable is the output value because it depends on the input. So one other thing I forgot to mention earlier, but basically the x values can be called the input, which obviously I've already said, or domain. I don't think I set that up here. Maybe I did. I did not. Okay. So the x values are our input or our domain. Okay, so that is, or our, now we also have independent variable. The y values are the output or range. So some of the problems are going to ask you to state the domain and range when they give you an input-output mapping diagram. Some of them are just going to give you a table and say the domain is blah, blah, blah. Here's an equation, solve for the range, okay, which is solve for the y values. So there's different ways that they can basically be asking us the same information with different words. So, an example, make a table for the function y equals x minus 5 with domain 10, 12, 15, 18, and 29. Then identify the range of the function. So they want us to make a table. So I've got domain or my x values, and that's what they've given me. I probably made that excessively long, but oh well. And then I've got my range or my y values, which is what I am trying to find. Now, they've given me the equation y equals x minus 5, so that's what I'm going to use to find my y values. Okay, so I've got 10, 12, 15, 18, and 29. So in my boxes down here, I'm going to replace x with this number in this equation to solve for the y value. So I'm going to have 10 minus 5, which is 5. Then 12 minus 5, and you don't necessarily have to write all of these in when you do them. If you can just do the quick math in your head, as long as you have the equation, I'm fine with that. 15 minus 5 is 10. 18 minus 5 is 13. And 29 minus 5 is 24. So that would be all you need to do to answer that question. Identify the range of the function. We've done that by doing the second row of the table. Stuff's really not hard. It's just kind of tedious because it's like filling in all the little things. Okay, let's jump into some actual problems here. Identify the domain and range of the function. So, number 4, they give us an input-output table. Or actually, it's a mapping diagram. Some of them are tables, some of them are mapping diagrams, but it's the same thing. If it's a table, it's whatever's paired beside each other that goes together. If it's a mapping diagram, you have to look at where they draw the arrows, which in this case, they're all drawn to what's beside them, but that isn't always the case. So the inputs are 3, 5, 7, and 8. the outputs are 7, 5, 3, and 2. And like I said, they all go across over here. So, not what it's asking for, but would this be a function?
Yeah.
Why?
Because it doesn't have two of the same inputs.
Yep. So this would be a function because no input values are repeated. So for the domain and range, we usually abbreviate that with a D and an R, just so that we don't have to write the whole thing out. My domain values are 3, 5, 7, and 8, and we typically want to write them in numerical order. However, if you don't, that's okay. It's just nice if they're in numerical order. My range values then in numerical order are 2, 3, 5, and 7. And that's all you have to do on those ones. The next ones, rather than stating the domain and range, but we still might at least talk about it, it wants us to tell if it's a function or not. So essentially up here we just said that this one is a function because nothing is repeated. So that one is a function. The next one, 6, we have a table this time. So the input values are 0, 1, 2, and 3. And the output values 7.5, 9.5, 11.5, and 13.5. So, is this a function?
Yeah.
Yep, because nothing is repeated. So this is a function. The domain values would be here, our input values, and then our range would be these output values here. But again, not what this particular question is asking us for. There's just not a ton of these in the book, so just using what we can. All right, the next question is a multiple choice question, but it still works. It's going to be similar to this example that I did here for you. So they say the domain of the function y equals 5x minus 1, so that's going to be our equation, is 1, 3, 4, 5, and 6. So those are our domain values. Which number is in the range of the function? So obviously this is multiple choice, so they give you options. Normally we would just have to do the whole table, and that would just be how we do the answer. But we'll do the table, and we'll circle the answer that it is. So I'm going to set up a table here with x and y. And if you want to call it domain and range, or however you want to label it, just saying x and y is also fine. I'm going to write my equation here so that I have it. So 5x minus 1. I'm going to put all my domain values in. So 1, 3, 4, 5, and 6. And then I'm just going to plug in these numbers and then see which of these 0, 4, 9, and 15 are actually in the range. So 5 times 1 minus 1 would be what? 4. I'm going to work the whole table out, despite the fact that we can already see quickly that it's 4, just for practice. 5 times 3 minus 1 is?
14.
5 times 4 minus 1 is?
13.
5 times 5 minus 1?
24.
24. And 5 times 6 minus 1? 29. So, like I said, you don't necessarily have to write out showing the number that you're plugging into the equation because you have the equation here, but I'm just doing it for reference for us for right now. Questions on those so far? All right, 16. Basically the same thing, it's just not written in this way. Make a table for the function, identify the range. So they're going to give you the equation, the domain values, and then you're just going to make a table and just find these values here. So 16, y equals 3x plus 4. The domain values are 0, 5, 7, and 10. So I'm setting up my table, x and y. Domain values going in, 0, 5, 7, and 10. I'm going to write my equation down here. And then I'm going to plug in the numbers. So 3 times 0 plus 4. Yep. 3 times 5 plus 4. 19. 3 times 7 plus 4. 25. And then 3 times 10 plus 4. 34. All right, I'm going to torture you for a second. I'm going to make you do this next one on your own, and then we'll go over it. Y equals 2/3 x plus 1/3. The domain is 4, 6, 8, and 12. So I want you to set up the table and solve for the values. You're lucky because they already have a common denominator. So hopefully it won't be too hard. Because I know everyone's favorite is fractions. So take a couple minutes and do this, and then after that I'll give you your problems. And you can leave your fractions improper if they don't, like, simplify all the way down. read the clock?
No.
Can you read a normal clock?
Yeah.
Wouldn't the numbers be in the same place?
157.
I guess.
Only when practices, and I can use that as one.
Taylor's like, I know what time practice is over, especially if we have to run. Because Coach Stacy's the worst. Because you need a condition anyways. Well, you'll be in good shape for then. And basketball season. All right, what did we get for the domain of 4? What was our y value?
3.
How about 6?
4 and 1/3.
I got 13/3.
Okay, yep. 13/3 if you left it improper. If you are like really obsessed with mixed numbers, 4 and 1/3. How about 8?
17/3.
17/3.
17/3. If you converted it to a mixed number, it's 5 2/3. How about 12?
25/3. 8 and 1/3.
Yep, 25/3 or 8 1/3. Seems like y'all got this down pretty good. You feel okay with it? We're getting there at least. All right, problems are 3 through 17 odd. Make sure you pay attention, it's odd.
Oh, yeah.
I mean, in fairness, I didn't do all the evens for you today, but